Hello, friends. We have started a series on the geography, and we will discuss on completely geography को पूरा complete डिस्कस करेंगे और जो ज्योग्राफी के जितने भी कॉन्सेप्ट्स हैं वो भी डिस्कस किए जाएंगे। और हम स्टार्ट कर रहे हैं। जो पहला हमारा टॉपिक है ज्योग्राफी के अंदर, जो सबसे इजी है बेसिकली, दैट इज इंडियन ज्योग्राफी के अंदर तो सबसे पहला टॉपिक दैट इज मॉनसून। तो मॉनसून के टॉपिक से स्टार्ट करेंगे और मॉनसून को डिस्कस करेंगे बिकॉज इफ मॉनसून आर अंडरस्टूड, एक बार मॉनसून ढंग से समझ आ गया तो उसके बाद मॉनसून से रिलेटेड जो कॉन्सेप्ट है, यानी कि वेजिटेशन, जो कि मोस्टली वेजिटेशन, ओके, सोयल्स और बाकी जितने भी मॉनसून और रेनफॉल से रिलेटेड कॉन्सेप्ट है वो सभी एक बार में ही समझ में आ जाएंगे अगर हमें मॉनसून का टिपिकल कैरेक्टरिस्टिक, मॉनसून का इंडिया के अंदर टिपिकल कैरेक्टरिस्टिक पता है। तो हम स्टार्ट करेंगे पहला जो टॉपिक है मॉनसून का, उसके साथ ही आज के पहली क्लास के साथ। तो पहली क्लास होगी वो मॉनसून से स्टार्ट है। सो वी विल स्टार्ट विद द मॉनसून टॉपिक। ओके, सो इंडियन monsoons. So first of all, let us discuss few of the characteristic of the Indian monsoon. Characteristics. तो सबसे पहला जो कैरेक्टरिस्टिक है इंडियन मॉनसून का वो ये है कि इंडियन मॉनसून दे आर टिपिकली द साउथ वेस्ट विंड्स, यानी कि यदि ये इंडियन पेनिनसुला है तो इस इंडियन पेनिनसुला के अंदर इस कोस्ट को मालाबार कोस्ट बोला जाता है। इस और सबसे पहली जो विंड्स होती हैं मॉनसून विंड्स, वो इस मालाबार कोस्ट को स्ट्राइक करती हैं। और इंडियन पेनिनसुला का एक टिपिकल फनल शेप होने की वजह से जो मॉनसून विंड्स होती हैं वो डिवाइड कर जाते हैं, यानी कि कुछ मॉनसून विंड्स इस तरीके से इंडियन पेनिनसुला को स्ट्राइक करते हैं तो कुछ मॉनसून विंड्स इस डायरेक्शन के अंदर कन्वर्ट कर जाते हैं। और यहाँ पे लेट से दिस इज दी श्रीलंका, तो कुछ मॉनसून विंड्स बे ऑफ बंगाल के रास्ते से एंटर करते हैं। ये बे ऑफ बंगाल है, यहाँ पे बे ऑफ बंगाल, ठीक है, दिस इज बे ऑफ बंगाल। और यहाँ पर जो बे ऑफ बंगाल इधर की साइड अरेबियन सी। तो इंडियन मॉनसून सबसे पहला जो हमें याद रखना, सबसे पहला कैरेक्टरिस्टिक कि इंडियन मॉनसून जो मलाबार कोस्ट है उसको 27th ऑफ मई एज पर दी IMD रिकॉर्डेड डेट है, लेकिन अब इसको भी डिले कर दिया गया है बिकॉज ऑफ क्लाइमेट चेंज। इस डेट को यहाँ पे स्ट्राइक करती है मालाबार कोस्ट पे। सो सबसे पहला कैरेक्टर। नेक्स्ट कैरेक्टरिस्टिक की जब हम बात करेंगे, दैट द इंडियन climate is a typical alternate wet and dry climate. ये मॉनसून टाइप ऑफ क्लाइमेट का टिपिकल फीचर होते हैं, चाहे वो मॉनसूनल टाइप ऑफ क्लाइमेट हो या फिर वो सूडो मॉनसूनल टाइप ऑफ क्लाइमेट हो। उनके अंदर ऑल्टरनेट वेट एंड ड्राई सीजन मिलेगा हमारे को। जैसे कि सूडो टाइप की बात करें तो गल्फ ऑफ गिनी, अफ्रीका के अंदर, जो अफ्रीका, दिस इज द मैप ऑफ समथिंग दिस शेप, ओके, दिस इज द गल्फ ऑफ गिनी। यहाँ पर भी एक सूडो मॉनसूनल टाइप ऑफ क्लाइमेट मिलता है। कोई भी मॉनसूनल कैरेक्टर हो, फॉर एग्जांपल इन इंडिया व्हाट हैपेंस, फर्स्ट कम्स द समर, ओके, नो मॉनसूनल विंड्स इन इंडिया। उसके बाद एक मॉनसून पीरियड स्टार्ट होता है 3 to 4 months, राइट, उसके अंदर मॉनसून विंड आती है, यानी कि ऑल्टरनेट वेट एंड ड्राई सीजन मिलेगा मॉनसूनल, राइट। दिस इज द सेकंड फीचर। थर्ड फीचर की बात करें तो थर्ड फीचर इज द रिवर्सिंग विंड्स। मॉनसूनल टाइप ऑफ क्लाइमेट्स के अंदर विंड्स ऑल्टरनेटली रिवर्स करेंगे, राइट। फॉर एग्जाम्पल दिस इज द मैप ऑफ इंडिया, राइट, लेट अस से this is Indian map. What happens in Indian map? See, monsoon enters, Arabian Sea branch enters through this route, Bay of Bengal branch enters through this route. लेकिन 15 सितंबर के बाद, आफ्टर 15 सितंबर, these winds, okay, which are bringing moisture, जो कि इंडियन पेनिनसुला के अंदर मॉइस्चर लेके आ रहे हैं, ये विंड्स वापस रिट्रीट करना शुरू कर देंगे और इंडियन पेनिनसुला पर कुछ इस टाइप की विंड्स स्टार्ट हो जाती हैं, इस टाइप से विंड्स। और जो ये विंड्स है, ये कॉन्टिनेंटल विंड्स है, इनके अंदर कोई मॉइस्चर नहीं है ऑब्वियसली, क्योंकि ये विंड्स तो ओशन की साइड से आ रही है, इनके अंदर मॉइस्चर है, तो ये दे ब्रिंग द रेनफॉल इन दिस रीजन ऑफ इंडिया, सो दे आर मॉनसूनल विंड्स। लेकिन जो ये विंड्स है, दे आर रिट्रीटिंग मॉनसूनल विंड्स, दे आर रिट्रीटिंग मॉनसूनल विंड्स, रिट्रीटिंग मॉनसूनल विंड्स। तो इन विंड्स के अंदर कोई भी बारिश होने का सवाल ही पैदा नहीं होता। इस वजह से मोस्ट ऑफ द विंटर्स प्लस समर्स इंडियन पेनिनसुला पे ये विंड्स जो कि कॉन्टिनेंटल विंड्स है, रिट्रीटिंग मॉनसूनल विंड्स है, दे स्टे ऑन द इंडियन पेनिनसुला और कोई रेनफॉल नहीं होगा। दिस इज द थर्ड कैरेक्टरिस्टिक ऑफ द monsoons, Indian monsoons, right? Then comes the basically we have to understand कि monsoon, how the monsoon enters, क्या theories है monsoons की। There are different theories जिसके बेसिस पे कि monsoon winds को explain किया जा सकता है, monsoonal winds को explain किया जा सकता है, right? सबसे जो पहली थ्योरी है, that is the thermal theory, thermal theory। According to this theory, monsoonal winds are nothing but they are the land and sea bridges, land and sea bridge, okay? For example, let us say this is the ocean here, okay? This is the ocean and this is the continent। ड्यूरिंग द डे टाइम, दिन के समय यहाँ पर क्या होगा, हाई हीटिंग की वजह से यहाँ पे लो प्रेशर डेवलप हो जाएगा और इस लो प्रेशर के कंपैरिजन में ओशन के सरफेस पे हाई प्रेशर रहेगा। तो ऐसा होने की वजह से एक कन्वेक्शनल सेल डेवलप हो जाएगी, इस टाइप की, इस टाइप से कन्वेक्शनल सेल डेवलप हो जाएगी, राइट, इस टाइप से। और इस कन्वेक्शनल सेल का अगर आप कैरेक्टरिस्टिक देखोगे तो ये कन्वेक्शनल सेल ओशन की तरफ से विंड्स लेके आएगी जो कि मॉइस्चर लेडन विंड्स होंगी। यहाँ पे ये विंड्स जो कि इधर मॉइस्चर की द ओशन की साइड से, जो कि कॉन्टिनेंट की साइड जो विंड आ रही हैं, उन विंड्स के अंदर काफी मॉइस्चर होगा और इसी मॉइस्चर को मॉनसूनल विंड्स बोला जाएगा अकॉर्डिंग टू द थर्मल थ्योरी, राइट? एज पर द थर्मल थ्योरी, these sea bridges, these are called sea bridges, these sea bridges are the monsoonal winds, right? This is the thermal theory, जिस जो कि है ना फर्स्ट थ्योरी, जिसके की हेल्प से मॉनसूनल विंड्स को एक्सप्लेन किया जा सकता है। लेकिन इस थ्योरी के अंदर बहुत सारी चीजों को नेग्लेक्ट कर दिया गया, तो ये थ्योरी प्रॉपर तरीके से मॉनसून्स को एक्सप्लेन नहीं कर पाएगी। सो इसी वजह से सेकंड थ्योरी जो दी गई मॉनसून को एक्सप्लेन करने के लिए, सेकंड थ्योरी वाज द फोन थ्योरी, फोन थ्योरी, फोन थ्योरी। According to phone theory, see what happens, this is the Indian peninsula, right? और यहाँ पे 0 डिग्री लैटिट्यूड है, 0 डिग्री लैटिट्यूड, ओके? सबसे पहली बात ये समझना जरूरी है कि 0 डिग्री लैटिट्यूड के आसपास के जो लैटिट्यूड्स हैं, इस रीजन को, दिस रीजन इज कॉल्ड एज द ITCZ, दिस रीजन इज कॉल्ड एज द ITCZ, राइट? इंटरट्रॉपिकल कन्वर्जेंस। व्हाई दिस रीजन इज कॉल्ड इंटरट्रॉपिकल कन्वर्जेंस जोन? Because the northeast trade winds, they and the southeast trade winds, they converge at this point, and these winds converge at this particular point at 0 degree, and then they rise, and then they start rising, and when they rise and they forms the cumulonimbus cloud over this latitude. Heavy cumulonimbus cloud forms over this latitude, and these clouds brings the daily rainfall, okay? So, and one thing that these winds, whether these are called the trade winds, these both are called the trade winds, they are trade winds, okay? Now there is what you are saying, that these trade winds flows from the 30 degree north latitude and from here also 30 degree south latitude, right? But when these winds are, you know, colliding at this point, and there is forming the cumulonimbus cloud and rainfall is happening, but during the summers what happens, this ITCZ zone, this convergence zone, this moves northward, this convergence zone moves northward. Now how this convergence zone moves northward? This is the Indian peninsula, right? Okay, this is 30 degree latitude and this is 0 degree, and ITCZ forms in this area, right? This is the ITCZ zone. But what happens in the summer? This ITCZ moves the northward, right, and establishes itself at this point in zone, right? Now, when this ITCZ establishes itself over this zone, what happens? That the monsoonal winds, the winds that were earlier moving in this direction, okay, they will now they have to reach the no ITCZ. Now, let me show you what happens here. This is the 0 degree latitude. This is 0 degree latitude. Now the winds which were flowing in this direction, they have to reach the ITCZ. This is ITCZ. Now while crossing the 0 degree latitude, when these winds, trade winds will cross the 0 degree latitude, due to Coriolis force, they will turn in this direction. Right? Due to Coriolis force, these winds will turn in this direction, and these winds are nothing but the monsoonal winds. And when they will strike over this peninsula and they will split here, one branch is called the Arabian branch, another branch will be called as the Bay of Bengal branch. So this is the phone theory, okay, for explaining the monsoonal winds. For explaining the monsoonal winds, the third theory for explaining the monsoonal winds is the Yin Jet Stream Theory. Third theory is the Yin Jet Stream Theory. Yin Jet Stream Theory. Yin Jet Stream Theory. Now, as per the Yin Jet Stream Theory, it is not just the ITCZ which plays an important role in the monsoons. Along with ITCZ, the jet streams also plays important role. Now, what are the jet streams? The jet streams are nothing but the upper troposphere winds, and these are the horizontal winds. That means these winds flows from west direction to east direction, upper tropospheric winds, right? And in these winds there are the presence of the jet streams, okay. For example, let us say this is the earth surface, right? This is 0 degree latitude, this is 30 degree latitude, and this is 60 degree latitude. Okay, in these latitude 30 degree, 60 degree, the pressure contrast is sharpest, and in these latitudes, in the upper tropospheric region, that means about 12 kilometers, there would be horizontal winds, okay. That means if you see let us say 5 kilometer, 3 kilometer, 4 kilometer, there would be horizontal winds. You would find the direction of winds from 0 to 30 degree, 30 degree to 60 degree. But when you go in up atmosphere, then you will see the horizontal winds, and like winds from the west to east direction, and they will be across the globe, no, all over the earth, in the upper troposphere. But in these latitudes 60 degree and 30 degree, there is the sharpest contrast. And this contrast, because of this sharp contrast, there would be the speed of wind would be fast. And these fast winds are nothing but the jet streams. So this is jet stream. So Yin Jet Stream Theory says that not just ITCZ but the jet streams also play a very important role in the formation of the Indian monsoons. Right. So what is this? Now look at this. This is the map of the Kashmir here. Okay, and somewhere here this is the Pamir Note mountains here, and this is a jet stream. This jet stream is called the subtropical westerly jet stream, and this jet stream gets divided at the Pamir Notes. This is Pamir Notes. When this jet stream, this is close to 30 degree latitude, right? And when this jet streams brings the moisture from the Mediterranean Sea, okay, Mediterranean Sea, okay. And this jet stream gets divided at these mountains, these Himalayan mountains here, and there are two branches that becomes of this jet stream. One is the northern branch, another is the southern branch of the STWJ, subtropical westerly jet stream. This is the subtropical westerly jet stream, subtropical westerly jet stream, right? So this is the southern branch of this. These are the Himalayan mountains. Because of these mountains, this jet stream gets divided. Now what happens in the north of the southern branch? In the north of the southern branch, okay, because you know this jet stream is in the upper troposphere, above the height like 14 kilometer, 15 kilometer above the surface. But on the north of this southern branch get established in the low pressure. When the low pressure aloft get established, at the bottom there would be the high pressure there at the bottom. And what at this bottom, this is the area of Tibet plateau. That means high pressure gets established at Tibet plateau, right? So हाई प्रेशर एस्टेब्लिश होने की वजह से मॉनसून विंड्स यहाँ पर प्रोसीड नहीं कर पाएंगी इंडियन पेनिनसुला के अंदर, राइट? सो मॉनसून विंड्स विल स्टॉप. नाउ व्हाट हैपेंस फॉर द मॉनसून विंड्स टू एंटर द इंडियन पेनिनसुला? This southern branch has to retreat from the Indian peninsula. Now this happens in this manner. This is the again Kashmir map here. Okay, as the ITCZ moves, I told you that ITCZ will, as the June approaches, the ITCZ will keep on moving northward. And ITCZ, as the ITCZ moves northward, the monsoon winds, there would be the one is the southwest monsoon winds that will keep on entering the Indian peninsula, because they will be merging at this point. Simultaneously, STWJ, subtropical western jet stream, okay, will also be keep moving on the north direction. So this STWJ will retreat from the Indian peninsula, and because of this retreat, there would be perfect condition. Wait a second. So the STWJ, which had earlier established itself on this part, will this STWJ, which was becoming the reason for not allowing the monsoonal winds to enter the India. Now this jet stream will retreat from this region, and this jet stream will move further northward. Okay, and the south of this jet stream will be established a low pressure. So on the this is a Tibet plateau. So on the Tibet plateau there will be low pressure, and this low pressure will attract the monsoonal winds from the ocean side. So okay, this would be the something characteristic here. This is the so this region will be having the low pressure. Okay, a low pressure cell will become here, and this low pressure will attract the monsoonal winds from this region. Now this region, monsoonal winds from all the sides, wind will entering the Indian peninsula. Okay, and this is the process according to Yin Jet Stream Theory. So this was the Yin Jet Stream Theory. Yin Jet Stream Theory. Okay. Now the next theory is the Kuteshwaram expedition. Kuteshwaram theory. So as per the Kuteshwaram theory, there will be a jet stream, that is the subtropical easterly jet stream. Subtropical easterly jet stream. Easterly jet stream. This subtropical easterly jet stream is also responsible, in addition to earlier two things, that is ITCZ plus this subtropical westerly jet stream. So इन दो additional चीजों के अलावा, the third thing, that is the subtropical easterly jet stream, that is also responsible for the monsoonal winds. Now how this jet stream works and how this forms is, now see, this is the African coast. Okay. This is the African peninsula, this is the Arabian peninsula, this is the Indian subcontinent here. Okay, and this is, here is the Tibetan plateau, this is Tibetan plateau. Okay, what happens, as we know, for monsoonal winds, this here should be the low pressure on the Tibetan plateau, and Tibet plateau is approximately 2000 meter high above mean sea level. what happens around this region? A high pressure will develop. A high pressure will develop, and this low pressure and this high pressure will get linked. And what happens here? At this particular point, winds will rise. Okay, and then these winds get linked with this high pressure, so there will be horizontal flow, almost horizontal flow like this, horizontal flow like this, right? And these winds will descend at this high pressure, these winds will descend at this high pressure, and from this high pressure they will again move towards the Indian continent at the surface, this. So these winds are the monsoon winds, these winds are the monsoon winds. Okay, and this jet stream that is getting established here, this jet stream is nothing but the easterly jet stream, tropical easterly jet stream, easterly jet stream. So what we are seeing that this jet stream is also responsible for bringing the rainfall, right? For bringing the rainfall. So this was the Kuteeswaran theory for explaining the monsoon winds. Now the third thing that affect the Indian monsoon, next thing that established the Indian monsoon is the El Nino circulations. So the El Nino circulation. So next thing that we are discussing affecting the Indian monsoon is the El Nino. So El Nino circulation. El Nino circulations. See, generally this is, let us say this is the earth surface, right? This is 0 degree and this is 30 degree. There are the horizontal cells that are vertical cells that are being developed. Okay, that warm water is being transferred from 0 degree to 30 degree, and similarly this is called this region is the Hadley cell. This region is the Hadley cell. Okay, what happens in the Hadley cell? The winds rise at the 0 degree and they descend at the 30 degree. So winds rising at this 0 degree, let us say, okay, this is the 0 degree and this is the 30 degree. Okay, this is 30 degree. Winds rise at the 0 degree, and then they move horizontally, and then they descend at the 30 degree. This is general process of heat transfer across the earth's surface. Similarly, so this is the 60 degree latitude. What happens at the 60 degree latitude? This is 60 degree latitude. At 60 degree, winds again rise, and they move horizontally, and they descend at this 30 degree latitude. This 30 degree latitude is the high pressure zone, and at this high pressure zone is also called as the horse latitudes. These are the meridional circulations, but there are not always these meridional circulation, these vertical circulation. There are horizontal circulations across the globe also. Okay, for example, if you see, this is the African coast here, right? This is the African coast here, right? This is the Australia, and this is the South America here. This is South America. Okay, and this is 0 degree here. In general, what happens? This region, as we know, this is the masculine high pressure. Okay, this is the masculine high pressure. When the winds, this circulation are normally in this manner. Okay, winds rise in this region of the Australia. Okay, and they descend at this region. This is the Peruvian coast. Okay, then these descending winds will strengthen this high pressure. Okay, descending winds will strengthen the high pressure, and we know the strong high pressure will bring the more rains to the Indian peninsula. Okay, more strong monsoonal winds will flow from here. But what happens in the in a circumstance of the El Nino? When El Nino get established, this cycle, this here get established a Walker circulation. Right. In the Walker circulation, what happens? This pattern of the winds get reversed. Now, how this pattern of the winds get reversed? Now, earlier, see, now in this time, here will be the descending limb. Here will be the descending limb on the Australian coast. Here will be the descending limb, right? And here will be the ascending limb. Okay, here the winds will rise, here winds will descend, right? Similarly, here again the winds will start ascending. So this high pressure will get weakened. We know for strengthening the high pressure, winds must descend at this place. But when this certain type of circulation get established at this point, okay, when the winds starts rising above the Peruvian coast, at the Peruvian coast winds are rising, so this region experience the rainfall during the El Nino year. This is the Atacama Desert region. Atacama Desert region experiences the rainfall during the El Nino year. But during the El Nino year, this high pressure gets weakened. इस हाई प्रेशर के वीक हो जाने की वजह से यहाँ पर जो मॉनसून विंड्स जो फ्लो करनी चाहिए थी इंडियन पेनिनसुला के अंदर, they also gets weakened. So El Nino years generally experience the droughts in India. These years experience droughts in India, right? Now this is the another factor that affects the Indian monsoon. The next factor that affects the Indian monsoon is the next factor is the Indian Ocean Dipole. Indian Ocean Dipole that affects the Indian monsoon. Now, how Indian Ocean Dipole affects the Indian monsoon is, look, this is again a complete diagram. Here, this is the African coast. Here, this is the Arabian Peninsula. This is the Indian coast here, right? This is Arabian Sea, and this is the here is the Australia. In this region, this is the Arabian Sea, and this is the east coast of the Australia. Sorry, west coast of Australia. In this region, a local secondary circulation get established. And how this local circulation get established? When this Arabian Sea has the high pressure and this region has the low pressure, again at the low pressure winds will rise and they get coupled at this point and they move toward this location, and because of high pressure they will start descending at this point, and again there will be horizontal circulation at this point. Now because of descending limb of the Indian Ocean dipole, this descending limb here, high pressure will establish, and this is a very big region. Okay, something like this. So in this region, if the winds are descending, so there will be dry condition in many parts of India because of this kind of circulation. But if the pressure pattern are reverse, for example, this is the Africa coast and this is the Indian Peninsula here. For example, here established on the east at this point is the high pressure. This is the west coast of Australia. Here is the Australia. This is the west coast of Australia. But in this region, there is getting established in Arabian Sea here low pressure. Low pressure. This is the high pressure region. So what will happen? The winds will start rising at this point. Wind will start rising at this point. So rising winds bring the rainfall. So this region will experience the cloud formation and the rainfall, and these winds get linked with high pressure, and there will be the dry condition in this region here, in this region of Australia. So this is called when the low pressure is here and the high pressure is at this point, this is called the positive Indian Ocean Dipole, positive IOD. When the high pressure is at this point and low pressure is at this point, then becomes the previous case is the negative IOD, when there will be the low rainfall in India. So this is the IOD concept and how it affects the Indian Ocean monsoon. The next concept or the next thing that affects the Indian monsoon is the Maiden Ocean Zone, MJO. Madden-Julian oscillation. Madden-Julian oscillations. MJO. So this MJO also affects the Indian monsoon, but how they affect the Indian monsoon? See, on the Earth's surface, there is in this tropical. This is the tropical region. This is the 0 degree. this is 0 degree latitude, this is 30 degree north, this is 30 degree south. In this region of the earth, there is a circulatory system, there is a local circulatory system which has one ascending limb and another descending limb. Okay, so this kind of cell, a local system which rotates this region of earth, tropical region of earth, is the MJO, maiden Julian oscillation. And see, this maiden Julian oscillation has two limbs, one is the ascending limb, another is the descending limb. So wherever there will be the ascending limb, there will be the rainfall, there will be rainfall, and wherever there will be descending limb, there will be the subdued rainfall or the no rainfall. Now for, see this, in 2020 what happens in India. So this is, see, this is the map of India. This is the map of India. This is the Assam region, this is Bihar region, and this is the Punjab Haryana region. This local circulation, that is MJO, as I told you, this MJO keep on circulating at this location across the globe. Now in the June, July or August time period, this MJO, ascending limb of this MJO get established at this point, ascending limbs. Okay, the winds start rising at this point and the winds would descending at this point of MJO. So this was the local cell or the local MJO system which get established in this manner. So this Bihar Assam region experienced the excess rainfall during this year 2020, and the Punjab Haryana region witnessed below average rainfall because of the simple reason MJO got established at this point. So this was the main reason. So these factors and these theories are mainly the theories which influence the Indian monsoon. So what we have discussed till now, the characteristic of Indian monsoon, characteristics of monsoons, right? Number one. Number two is the theories of the Indian monsoon, theories of Indian monsoon. Okay, we started with the first theory, that is the thermal theory. Then we explained using the jet stream theory, Yin, and then we explained the Kuteswaran theory. Okay, we explained the El Nino effect on the Indian monsoon. Along with El Nino, we also explained the Indian Ocean Dipole. Along with Indian Ocean Dipole, in last we explained the maiden Julian oscillation, MJO. So all these factors are the main reasons which affect the Indian monsoon. Now the next that can be discussed under the Indian monsoon is the how these Indian monsoons affect the vegetation of India. Right, vegetation of India. Plus, along with this, one more thing in the monsoon is the variability of Indian monsoon. So this is again important, that how Indian monsoons vary in the India, across India, right? So this we will discuss in the next class, that vegetation, how the monsoon affect the vegetation, and what is the variability of the Indian monsoon, right? So this is for this video. So if you like the video, subscribe the channel, and we will meet in the next class. So thank you.